Okay, so moving on to example 3. Well, before we start example 3, we're going to make 2 quick lines just like I've done here. So label one positive slope and the other one negative slope. And then the point of this is just to remind you that normally when you graph a positive slope, the natural temptation is to go up and to the right. But don't forget that you can go down and to the left and still create the same positive slope. And then it's the same idea when you're graphing a negative slope. Naturally, people tend to go down and to the right, but if you don't have room on the graph to go down and to the right, you can also go up and to the left. So then now we can move on to example 3, where we're graphing the 2 equations in each part. So in part A, we're going to graph these 2 and then determine the number of solutions. So the first equation is y equals 2/3 x plus 5. That means that we will start at 5 on the y-axis. And then here's where we would normally go up 2 and to the right 3. But clearly we can't do that on this graph. So we're going to go down 2 and to the left 3 and put our point there. And then from there, we would try to go down 2 and over 3 again to make the line as accurate as possible. But since we don't have room to do that here, then we just stop at those 2 points. And then with a ruler or a straight edge, you should connect those 2 points. If you don't have a ruler or a straight edge at your desk, then pause this video and go get one off the back counter, please. Because since the answer is where the 2 lines intersect, then obviously it's important to make sure that our lines are as accurate as possible. So then next, graphing the second equation, y equals 4/3 x plus 3. That means that we would start from 3 on the y-axis. And then, again, normally we would go up 4 and to the right 3, but that does not fall on the graph. So instead we have to go down 4, 1, 2, 3, 4, and to the left 3. So that now, again, with the ruler, you can connect your 2 points. And then in this case now we're trying to determine the number of solutions. So remember from the top of the page that we said that if it makes the exact same line, then that would be infinitely many solutions. Clearly these are 2 different lines, so it's not the exact same line. No solution was if the 2 lines are parallel. Hopefully you could tell that these 2 lines are not parallel. So that means that this is a 1 solution type problem. So the purpose of this example is just to show you that just because you can't see where the lines intersect doesn't mean that they don't intersect. The intersection is just off the graph. So this is 1 solution, and then I'm just telling you that the answer is 3, 7. Obviously, if this happened on your paper, then you wouldn't be able to tell what the answer is. You would just write 1 solution. So then moving on to part B. We're graphing y equals x. So remember, if it helps, you can always put a 1 in front of the x, or you can make it 1 over 1 for the slope. And then if it doesn't say plus or minus anything, then you can always make it plus 0. Because then we're doing 1 times x, which is still x, and x plus 0, which again is still x, so we haven't really changed the equation. So to graph that, that means that we would start from 0, and then we would go up 1 and to the right 1 since it's a positive slope. And this time we can put many points on here, so we put as many points as possible to keep our line as accurate as we can. And then since we have space going in the other direction, then you can even go back to the beginning and go down 1 and to the left 1, and you can see that it's still making the same slope. And then once you have all those points on there, then we go ahead and connect the points. And then the second equation is the same idea. Again, you can put a 1 in front of the x if that helps. And then this time it says plus 2, so that means that I'm going to start from 2 and then go up 1 and to the right 1 until I run out of space. And then the same idea again, I can go back to the beginning and go down one and to the right one. And then once you have your points on there, then you connect them. And then hopefully you can see that these two lines are parallel, which is why they have no solution. All right, so now moving on to the last example. This is where things get a little more tricky, because now this equation 2x plus y equals 1 obviously doesn't start with y equals, so we would have to do the wall and the floor to get y by itself. So somewhere off to the side where you have space, you write 2x plus y equals 1. And then you draw the wall and the floor. So the goal in this is to get y by itself. So in order to get y by itself, all I need to do is subtract 2x from both sides. So that over here, the 2x minus 2x cancels out, so that just leaves y. And then over on the right side, the most common mistake people make is that they try to subtract 1 minus 2x. But we know that we can't do that because those are not like terms. They don't both have an x. So we're just going to write out the 1 and the minus 2x. Since we want this to be in slope-intercept form, then we start with the x. So since this is a minus 2x, then I'm going to start by writing minus 2x. And then since that's a positive 1, then I make it a plus 1. So then now this is the line I'm graphing, y equals negative 2x plus 1. So that means that I will start from 1. And then since the slope is negative 2 or negative 2 over 1, then that means that I can either go down 2 and to the right 1, or I can go up 2 and to the left 1. And then once again, we repeat that until we run out of space in either direction. And then with the ruler, we connect all the points. And then one more time with the second equation. Again, it doesn't start with y equals, so we're going to have to do the wall on the floor to get y by itself. So in this case, you treat the x's like we did as we treated constants when we were solving equations. So that means that we're going to add or subtract whatever the x value is. So in this case, since it's a positive 4x, then I subtract 4x from both sides. So over here, 4x take away 4x cancels out. That leaves 2y. And then equals. And then once again, these are not like terms, so I can't subtract them. So I write them with the negative 4x first. And then that's a positive 2, so I write plus 2. And then lastly, again, I need a wall floor because I still don't have y by itself. Since this means 2 times y, then the opposite is to divide by 2. And then remember, just like we said at the top of the page, when you divide, you have to divide everything by that number. So in this case, that means that I'm dividing all of these numbers by 2. So that over here, 2 divided by 2 will cancel out, which just leaves y. And then over here, negative 4 divided by 2 is negative 2x. And then 2 divided by 2 is 1, so I write plus 1. So then now, hopefully you can see that these equations came out exactly the same. Y equals negative 2x plus 1, which means it makes the same line. which is why this is infinitely many solutions. Okay, so at this point, if you have any questions, you can raise your hand and ask. Otherwise, I hope this video was helpful. If there's any suggestions or anything, comments you would like to make, I welcome your feedback. Thanks.